journey of multiplying and dividing. We'll do multiply here, we'll do divide here. The beauty of the bicameral system, children, is that it takes two houses to pass a bill. Oh, wait, no, that's a whole different speech. Multiply and divide decimals. What is the phrase that pays when you multiply decimals? Let's say you have 7.3 times 8.6. When we add and subtract, we line them up. When you multiply, Amelia Goss, the yawning person of the world here, what?
You write them up and down.
No. Well, you do, but that is not our, what's the phrase that pays though? What's the key word that you should remember when you multiply? Abram, anything? Wade? No, you don't line them up. Sometimes they will end up lining up, but that is certainly not what you do. That's adding, subtracting, is lining up decimals, Carteret. We're looking to dig a little deeper than that one. Faith?
You put the last digit, you line up the last digit.
Oh boy. Time to review, I guess. You count decimal places. Good, seems we'll remember something here. Yes, you do, you write it down, it's 7.3 times 8.6. It doesn't matter where the decimals are when you multiply. In this case, they happen to line up on top of each other. Sometimes they do, sometimes they don't. You don't line them up. You just multiply this like it's 73 times 86 to get the digits, and then you figure out where the decimal goes. Wait, don't worry about them up there. They'll be okay without you. Look at him. What is he doing? Just kidding. Here we go. So you multiply 73 times 86. What's this? 1843. Put a 0 down there. 24, 2, 56, 58. So here are my digits. 8, 7, 2, 6. I hope I did that right. So where does the decimal go? How do I know? This is where you count decimal places. How many digits fall to the right of the decimal in each one of them? Well, this one has 1. This one has 1. That's a grand total of 2. So there has to be 2 digits to the right of the decimal also in your answer. So the easiest way to do that is you start here and you just count back 2 places. So your decimal goes right there, 62.78. 62.78. Another example, let's do one that's really goofy here. What if it was 0.6 times 0.009? Well, if you write them up and down, it doesn't matter, I'll put this one on top because it's got more digits hanging all over the place. Notice the decimals don't line up there, they don't have to. 6 times 9 is 54. Those are the digits in my answer. I have to figure out where the decimal goes. Well, just like we talked about before, this has 1, 2, 3 digits to the right of the decimal. This one has 1. For a grand whopping big total of, Carter W, 4. So I start here, and I have to come back 4 places. 1, 2, uh-oh, I ran out of digits, 3, 4. You have to fill in empty blanks with zeros if you have more places than you have digits. The answer to this is 54 ten-thousandths, or 0.0054. Do you remember that from last year? Do I have to do more? Is that a yes or no?
No.
How about, I'll give you one to do. You give me the answer to this. How about, let's say you have 3.68 times 30. Give me an answer for that. Let's see how many people get this correct. Should be about done. This is not done. 3.68 times 30. By the way, 7th grade, it's never a bad idea to kind of estimate what your answer should be. I would look at this and go, oh, well, if it was just 3 times 30, my answer would be 90. That's pretty easy. So if you get something that's way a ways away from 90, you know you did the problem wrong. I mean, a ways away. If you get like 900, that's probably wrong. Okay, I mean, if you get 100, that's probably close enough because you got this 0.68 hanging out over there or whatever. But you should be able to look at it and say, does my answer make some sort of sense here? Abram says,
108.40.
sounds reasonable. Let me do it. 3.68 times 30. Drop a 0 down. 24, 2, 18, 22, 9, 10, 11. Did you say 110.40?
Yeah, 108.40.
Did I do it wrong?
No, I don't know.
0, 24, 2, 18, 2, 9, 10, 11. Apparently the multiplication is a little suspect. I mean, anybody else get 110.40? Okay, thank you. Wade, what'd you get?
110.4.
Oh. Wait, did you not raise your hand?
I did.
Huh?
You did.
You did? Oh, I just missed it? Now, what's the rule for division, children? When you divide by decimals. There's a couple different things you gotta remember. Tyler?
Move the decimal to the right as far as it can go.
Move over is one thing, and then move up. Not always do you have to move over, but depending on the problem. So let's do this one. If it is 37.5 divided by 0.05. The first thing you have to remember is because with decimals, you know, back when you were in 2nd grade, you always divided a small number into a bigger number, but with decimals, it doesn't really matter. So how do I know which one of those two goes under the box and which one of them goes on the outside of the little division box? How in the world do I know which one it is, Wade?
37.5 goes on the inside
How do you know?
because it goes 37 divided by.
Yeah, I guess one way to remember it is, first of all, you could do this. 35 divided by 5 is 7, right? When you do that, which one goes under the box? This one. This one goes on the outside. They really flip places when you write them out the other way. So 0.05 goes on the outside. 37.5 goes on the inside. Now, this one, because this has a decimal out here, you need to get rid of that. We don't do division until this decimal is completely gone. What's the fix? That's that whole move over thing. You just move the decimal over until it gets out of there and that becomes a 5. But you have to remember, if you do it out here, you also have to do it over here. So now the problem becomes 5 into 3,750. By the way, when you're doing that, children, you're just simply multiplying both of these by 100. And that doesn't change your problem. Just like this. I can multiply this by 100 and get 3,500. I can multiply this by 100 and get 500. Guess what 3,500 divided by 500 is? 7. You don't change the answer when you multiply both of them by the same thing. It just allows us to do this. And then you're supposed to move up the decimal. So here, when you get the decimal where it goes here, you bring it straight up and that's where it goes in your answer. So now 5 goes into 37 7 times, which is 35. Write down your number here. 5 goes into 25 5 times. Is my answer, because I have nothing left, is my answer 75? It is not. Why, Jacob?
You have to bring down a 0.
I still got one more number here that needs to be brought down. 5 doesn't go into it, so you put your 0 up there. It's actually 750. See how much stuff you learned last year that you really didn't know that you knew, that you really didn't care that you knew, that you wish you knew some other time than right now? Let me give you one to do. How about this one? 1.44 divided by 6. 0.144 divided by 6. Give me an answer for that, please. 5, 4, 3, 2, 1, you should be there. Somebody out there who has not answered a problem yet today. Brant, what'd you come up with?
24.
What's that? Point what?
2400.
Point 24?
Yeah.
Huh? Huh?
0.024.
That'd be 24,000.
Yeah.
If that's what you want. Let's look and see. So 6 into 0.144. This doesn't have a decimal, so you don't have to do that moving over thing. You just scooch it straight up. 6 doesn't go into 1, so yeah, there's got to be a 0 up there. 6 goes into 14 twice, that's 12. 6 goes into 24 4 times. Now, some special cases here. How about this? Please be wary with this. People don't always think about this a whole lot. Automatically, people look at that and they say, oh, 0.3 squared, well, that's 0.9. Negative, negative, negative. Why is that wrong, Tyler?
Because there's two numbers with one decimal each, so that's two decimals, so
Right.
0.7.
Yeah, because if you multiply this out, 0.3 times 0.3, which is what that means, yeah, you get a 9 there, but that's 2 decimal places, so you gotta come back 2 places. So it's 0.09. The other thing is, what if a problem looks like this? 3.6 times 10 to the second power. Or 3.6 divided by 10 to the second power. 10 to the second power is
100.
100. And hopefully at this point in your mathematical lives, you should smile a teeny bit when you see multiplying and dividing by 100. Because please don't sit and write that whole problem out. This is one of the very few times you need to be able to do this without. I mean, you're gonna write it out that far. You should know exactly what your answer is now, because when you multiply by 100 or 1,000 or 10,000, what happens? Faith?
Move the decimal places, the amount of zeros.
Yeah, you're only moving decimals when you multiply or divide by 1,000 or 100 or whatever here. There's 2 zeros, you move the decimal 2 places, 1, 2, your answer is 360. This is the same thing, move it 2 places, but it's division, so the decimal goes backwards 2 places. It's 0.036. I mean, these are things you don't want to sit there and try to do. I mean, it just gets way too confusing, because then you're doing, okay, 100 into 3.6, you're doing this and you get all the zeros and it gets all messed up.